In our next example, we want to determine whether, I think that's supposed to be triangle DEF with vertices D of negative 4, 0, E of 6, negative 1, and F of 3, 3 is similar to triangle LMN with those corresponding vertices. You don't have to be an artist, but I'm going to graph these out just so we can get kind of an idea of what they look like. So I'm going to have negative 4, 0. I'm going to have 6 and negative 1. And my third point is going to be 3, 3. I'm going to connect those so we can see that. And then I want to compare that to my other triangle, which is going to be at negative 3 and negative 5. And then we'll look at 15 and negative 7. And then we'll look at 11 and negative 1. So now what we're going to do is we're going to compare the side lengths, which means we're going to have to do a bunch of distance problems. Yay! Real fun. So I'm going to start here, and I'm going to look at the length of D to E. Using your distance formula, subtract your x's. Well, let me label this too before I forget. So D is at negative 4, 0. E is at 6, negative 1. And F is at 3, 3. So I'm going to find the distance from D to E. So I'm going to say 6 minus a negative 4. Square that. Plus, and then I'll subtract my y's. It'll be negative 1 minus 0 squared. Now, 6 minus a negative 4, well, that's 10 squared. Plus negative 1 squared. So that will be 100. Whoa, got that off a little bit there. So I'm going to have 100 very good. 100 plus 1. So I'm going to get the square root of 101. Now let's compare that to LM. So I'm going to do the same thing for L to M. I'm going to use my distance formula. So L to M would be 15 minus a negative 3 squared. Plus, we'll go negative 7 minus negative 5 squared. So 15 minus a negative 3, that would be 18 squared. Negative 7 minus a negative 5 would be negative 2 squared. Well, 18 squared is 324. And negative 2 squared is 4. Remember, when you square negative, it always is a positive because a negative times a negative is a positive. Now, I'm going to look at my ratio between these two. So I'm going to look at the ratio. Well, first of all, notice this is the square root of these. My pen will not work. Is the square root of 328. So I'm going to look at the ratio of 101 to 328. And so 101, let me see here. What goes into 101? I don't know if much does it? 3 doesn't. So if I take 101 and I divide it by 328, it doesn't reduce. It's the square root of 101 to 328. Now we'll take a look at another pair of sides. Let's do the length from D to F. So d to f would be 3 minus a negative 4, so that would be 7 squared, plus 3 minus 0 squared. So we're going to get 49 plus 9, which would be the square root of 58. And let's compare that to ln. So ln would be the distance, subtract my x's, so 11 minus a negative 3 squared, or 14 squared, plus negative 1 minus a negative 5 would be negative 4 squared. So then we're going to get 196 plus 16. And 196 plus 16 is the square root of 202. Now, is the square root of 58 over the square root of 202, is that the same? And I would say no, they're not the same. So I'm going to say these are not similar. Because the ratios have to be the same. If your first pair of ratios aren't the same, we're done.